In this video, we're going to talk about the squeeze theorem. So the idea of a squeeze theorem is that you want to know basically what's going on with a function that's maybe kind of wiggly and crazy. Okay, so we're saying that we want to know what's going on with this function near A. Okay, the idea of the squeeze theorem is that if you can basically create or know of a function that's above it, know a function that is below it, then what should happen is if these endpoints are going to the same value, then that means that the middle guy has to also be going there. In my notes, I mentioned that my husband and I met in college. We were both math nerds. No, he's not a teacher. He actually works for a defense contractor. Yay. But what happens here is he called this the Moreno, because that's his last name, Cleveland theorem. And why Cleveland, I have no idea. So what he thought of is that he said, hey, look, I'm a train car, right? So I'm sitting in this train car. And we're going to have h of x be the engine and f of x be the caboose. Well, hey, if the caboose of my train and the engine of my train are going to Cleveland, then I'm in the middle, I'm going to Cleveland too. So that's what this is saying. This is saying that, hey, if this caboose goes to Cleveland, if this engine goes to Cleveland, then I'm going to Cleveland. Okay. Now, seems simple enough, but it turns out that the trickiest bit here is squeezing your function correctly, because there's lots of functions that are above and below a given function. Not only do I have to squeeze it correctly, but they have to be going to the same place, because I could have an engine going to Pittsburgh and the caboose going to LA. So I need to make sure that they're both going to the same spot. All right, so let me go ahead and illustrate this just so that you're aware. In the homework, your squeeze theorem problems are already created in an inequality, okay? So they'll already be given an inequality, and all I have to do is just show that the edges are going to the same spot. That means the middle is going to that spot, okay? However, in my notes, you will see that we want to figure out what the limit as x approaches 0 of x squared sine of 1 over x. We're supposed to show that that thing's going to 0. Okay, so the first thing we're going to do is we need to squeeze this. We need to find an engine and a caboose. Okay, so the first thing that I'm going to do is I'm going to grab that sine of 1 over x. And we know that sine of anything can't be bigger than 1, can't be smaller than -1. So already I've got an inequality. All right, now, how am I going to make this function match this function? I need an x squared. So if I grab an x squared and multiply each piece by this, I'm going to get negative x squared is less than or equal to x squared sine of 1 over x, which is less than or equal to x squared. Okay, so congratulations, I have now created my engine and caboose. Now I need to see if the engine and the caboose are going to the same spot, therefore the middle's going to that spot. So let's see, I want to know the limit as x approaches 0. So what is the limit as x approaches 0 of this outside edge of negative x squared? Well, what happens when I plug in 0? 0 squared is 0 times the negative is still 0. What about this guy? The limit as x approaches 0 of x squared. That's 0 too. So hey, congratulations. My caboose is going to 0, my engine's going to 0. That means that the limit as x approaches 0 of x squared sine of 1 over x equals 0. Woohoo! We did it. Okay, again, for those of you who are a little bit freaked out about creating this inequality, your homework problems, the inequality is already given. So you'll be given this step. All you have to do is find the limit of the outsides, and if they go to the same place, then that means the inside has to go there too. All right, good luck with the squeeze theorem.